Hello students, welcome back. Now let's go to exact differential equation and let's solve it. A quick reminder, this is where we are headed. We are looking for an implicit solution. F of x comma y is some constant c, and partial derivative f sub x is m and f sub y is n. That's the setting. Remember? Okay, let's go. We have this problem here. And then let's begin. F sub x is this. And f sub y is this. Okay. The x part is x, and then the y part is y. It's easy to remember. This is y prime there. That's the y part. Okay, all right. And then let's look for f, and how do I find that? Its derivative is here, so you can take the antiderivative by that character, and that's going to give me my f. So this is f sub x, partial derivative with respect to x. So integrate it with respect to the same variable x, then I'm going to get the original function f back. So we have this. And then let's do the computation. What is the antiderivative of 3x squared? It's x cubed, right? What's the antiderivative of 4xy? Y is just coefficient. Variable here is just x only. So it is 2x squared y. Does it make sense? Take the partial derivative and then 4x and then y stays because it's coefficient. And finally minus 2x because x is a variable. Now we have to have an integral constant here, but this is not going to be a constant because any expression of y alone will be killed because as far as x is concerned, all y expressions are just constants. So we're going to get a certain function of y here. And let me highlight it in a different color. Okay. Now we have another partial derivative here, so let's use that. F is equal to antiderivative of f sub y dy. So that's antiderivative of this. Okay, what is the antiderivative of 2x squared? Is it 2/3 x cubed? No. You do that when you take the antiderivative by x. You're taking it by y, so 2x squared is just a constant, so times y. How about this one? 2y cubed. Okay, raise the power by 1 and divide. And then we have to have a constant, but constant is going to be a function of x alone. So we have two expressions. And then let's compare and check. This one is common. Okay, how about 2y cubed? That's got to be the function of y alone, the g of y. Now how about these, x cubed and then minus 2x? Those must be this h of x, the function of x alone. Alright, so we are ready. F of x comma y is equal to 2x squared y plus 2y cubed plus now h of x. So x cubed minus 2x And then finally, we need real C. But we don't really need real C, do we? Because what we are looking for is implicit solution like this, equal to C. So we don't need that. Keep this thing equal to C, and this arbitrary constant C will absorb any integral constant. So we'll call this as a solution. Here we go. This is the implicit solution. Let's see. Is there a good way to check this? Yeah, okay, let's check this. So let's take this. Okay, 2x squared y of x plus 2y of x cubed plus x cubed minus 2x, and then equal to c, all right? And that's the equation. Take the derivative with respect to x, and this is the result. And then I'm looking for y prime of x, so solve this expression. Percent means previous result with respect to x prime of x, and then we got this result down here. And does it match this thing over here? It looks like it. The numerator is 3x squared plus 4xy minus 2. Okay, alright, match. Except for the sign, of course, but we'll have to flip it over to the other side, so sign actually matches too. How about the denominator? 2x squared plus 6y squared. Yes, that matches too. So yes, everything checks out. This is a solution. Now, can you do the next problem here? F of x will be this. F of y will be n. So what is f? So partial derivative of capital F with respect to x is this one. So in order to get original, we have to take the antiderivative with respect to the same variable x. So let's do that. And take this. And how do you calculate it? Well, I'll stop here. How about the other? F is gonna be antiderivative of f sub y dy for the same reason, and that's antiderivative of n, that one. And what is it? Again, I'll stop here. This integral computation will be a bit more challenging because, well, as you can see, we have some transcendentals flying around, so you may have to use some difficult techniques here. Maybe some integration by parts, substitution, who knows. But I'm going to leave the details to you. And then you're going to get some expression. So basically, you're going to get some expression plus integral constant should be g of y, function of y alone. And this is going to be an expression too. And then integral constant will be function of x alone, because that part, blue part, will be gone if you take the partial derivative by y, and red part will be gone if you take the partial derivative by x. And then compare. Common expressions, okay, they're all okay. and then there are some expressions flying around, compare those, and then get this blue function, and vice versa, get this red function. And if you still have something left over, then something is wrong. There should be all those matching, and then if you have equal to C, and that's going to be it.